Park? Oh, by the way, let me commend my, I call them TAs, SIs, TAs. Park, Susan, if I did not have these two, as much work as they've done, where they go out of their way, and I think even if a student would email them, say, Mr. Park, can I meet with you, maybe not during your assigned time, but can I meet with you somewhere else at some other time? Susan's the same way. They do. I attribute a lot of the good grades in here to these two. They helped me out a lot. Okay, Mr. Park's gonna be with me again during the winter. Susan's taking a vacation. So I have a replacement for her coming in. Okay, but she'll be back with me during the spring. Okay, so these guys are working hard, guys. And if you ever have a question, reach out to them. He does the video, I don't do the video. He does the video. Did you get any questions about the video?
So I uploaded a video, but it was in private, so nobody could see it. And so I got an email today, and I changed like last week's to like public, and this week's to public.
Oh, okay.
I'm sorry, class.
Okay. Yeah. I know we're not perfect. Okay. So now it's out there, though.
Yeah, it's out there.
Now, when he sends this out, I think you also send out the a copy of the handouts.
Mm-hmm.
Okay. Okay. I think we had a question about that. So, okay, guys. Now, I'm gonna jump into this. Nathan, since you're on that side, you usually pass out over on that side. One each. Mr. Park, you don't mind, one each. Thank you. Yeah. Okay, guys, let me do a quick recap. Here's the concern, and we were doing some of this on Monday. With these inverses, since we had to chop off a piece of the graph to make it one-to-one, that sort of threw the domain off on these. So we had to be very, very careful. We were doing a few exercises with this, and I think we now created this handout, which I can see. Yeah, it says section 6.2 continued. I did something unusual first. At the top there, in part 1, it says find the exact value of it. Just go ahead and copy it down. Jacob, tell me what it says there. Is it cosine?
Find the exact value, or are we on the new
Yeah,
hand?
that's very top there. I thought about this, yeah.
Find the exact
Was it-
value. Wait, I'm hard.
It's inverse cosine, wasn't it?
Yes.
And then cosine of what?
10 pi over 9.
There you go. I'm looking at that. I thought about this after I created the handout.
Yeah.
That's why I went back and placed it at the top. Now, this is what's going to face you next Wednesday. On these inverses, they'll drive you nuts if you're not careful. Can anyone tell me first, just the way it's written, what comes to mind? Matthew?
Isn't it just 10 pi over 9?
Tell me again?
10 pi over 9?
I would think it is. Now, tell the class why though, Matthew.
Because we're reverse cosining a cosine, meaning they cancel.
Now, let's do it like this though. You're saying it like this. You're saying, Professor, it seems like I remember something that happens when I do something like this.
Just equals x.
It's that x. That was a property of inverses that you guys, I think I asked you to do it on an exam maybe. After you found the inverse, I asked you to check it. And we check it like this. Matthew, I agree 100%. You say, wait, Professor, this looks identical to this property. Therefore, the answer should be x, and x is 10 pi over 9. Is that true? Okay. As a student, I would do the same thing, Matthew. Can anyone tell me what I maybe should be concerned about before I accept that answer? Looks like it should be 10 pi over 9. Who can think about what I should be worried about? This goes back to Monday's lesson.
The domain.
Well,
Yeah, was there a restriction? This is inverse cosine. Does anyone remember the domain and the range, especially the range? But first, the domain and the range that we established, that this committee established for us, for if you see inverse cosine, based on the piece of the graph we chopped off. Well, the domain was what? -1 to 1. And the range was?
0
to pi.
Gotta know this, guys. Gotta know the domain and the range for each one of those: inverse cosine, inverse sine, inverse tangent. And also there's some inverse cosecant, inverse secant, inverse cotangent, so forth and so on. I'm holding you responsible only for the principal three, okay? Now, so what's the issue? Well,
It's
the
not the
issue
domain.
says the answer should fall between 0 and pi with this restriction. Matthew, if I did, you and I would do the same, probably the same thing. If you have the answer right here, let's make it look a little bit more reasonable. It says really you're going up to what, 9 pi over 9. Is that true? 10 pi over 9 does not fall here in the restriction, so I can accept it. That's the problem with inverses. If it doesn't fit that restricted interval, you can't accept it, even though it looks reasonable. I can't accept it. Now, is there an answer? There is an answer, but it's not 10 pi over 9. Okay, guys, if this does not fit that particular restricted, in this case, that restricted range. Now, what I'd like to do is just quickly sketch it, see what it looks like. Guys, can anyone tell me which quadrant do you think, if I'm careful, would 10 pi over 9 terminate?
3.
I hear 3. And you guys who may not see it as quickly, you know this is pi here. So that could be represented as what, 9 pi over 9? And I want 10 pi over 9, so it makes sense. It's going to move me down into quadrant 3. And that's where my angle 10 pi over 9 is located, and we know we can't use it. So Ramsey, why sketch it? You can't use it. It doesn't fall here in the restriction. I can't use it. Is there a little reference angle that might help me move around a little bit and get an answer? In other words, does anyone know the size of this little angle right here?
Wouldn't it be 1 pi over 9?
1 pi over pi over 9, absolutely. Want to agree, guys?
Yeah.
You got 9 pi over 9, that's pi, plus pi over 9 gives you 10 pi over 9. So that little reference angle, we'll call it a reference angle there. Now, here's the restriction. If you're caught between 0 and pi by restriction, the answer must fall in either quadrant 1 or quadrant 2. Everyone agree?
Mhm.
This is 0, this is pi. So if I'm caught between 0 and pi, as I should be caught here by restriction, my answer should be in quadrant 1 or quadrant 2. But graphically, we're in quadrant 3. We're in the wrong quadrant.
Why not use
Now, can someone tell me how can I maybe maneuver and get into the correct quadrant and get an answer that might work? Austin, go for it.
From pi, go up 1 pi over 9.
Okay, he says, professor, take this little reference angle, and he said, wait now, of these two quadrants where I should be, 1 or 2, he says, professor, if you move up to quadrant 2, we'll check it first. Quadrant 2, cosine down in quadrant 3, which is where we're at right now, cosine, the x-coordinate, is negative. Is that true?
Yeah.
Now, which of these two, that where I should be, am I to retain that negative? Is it quadrant 1 cosine is negative, or quadrant 2?
quadrant 2?
Quadrant 2, so that means, as Austin's telling me, he's the professor, you better move up to quadrant 2, where you belong. And consider now that as your answer. Now, he says also when you move up, Professor, you're moving that pi over 9 up here. They're the same size. Now, can anyone tell me the size of the angle then from the beginning all the way out? What size angle am I looking at with that reference angle of pi over 9? 8 pi over 9, is that true?
Yes.
Now, would 8 pi over 9 fall within this restricted interval? Yes. You're talking about tricky? There is an answer. It's 8 pi over 9. Not 10 pi over 9. You Sujan, do me a favor. Think of a good way to do this. Do it in radians. Do the inverse cosine on cosine of 10 pi over 9. And the calculator probably will give you a decimal.
Cosine?
Cosine 10 pi over 9.
Radius or degree?
Do it in radians.
Negative 0.94.
Whoa, 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 whoa. Okay, hang on. Did you do inverse cosine?
Oh, I did cosine.
You did cosine first. Yeah, do inverse cosine first. Then cosine of 10 pi over 9. It's a little tricky on that calculator.
I got undefined.
Whoa.
Hey, am I doing something wrong?
You wanna do it in degrees? We change things to degrees. 9 into 180, you guys have, is that 20? 10 times 20, 200. Do inverse cosine on cosine of, what did I say it was? 200 in degrees.
Oh. I got 2.0 degrees.
But should work either way though. What'd you get?
160.
160. Okay, hang on now.
That's 8 pi over 9.
Yep. And if you convert that to degrees, if you wish, 9 into 180 is a quick way to do it. What's that, 20? 20 times 8, that's it, 160. So 8 pi over 9 is the answer. Laura, you gotta be careful on this test. Now, is Ramsey gonna place the restricted interval on the side there so you will make sure? No, or I will make sure, you will make sure that you are in the correct interval? No, you gotta know these 3 restrictions for inverse sine, inverse cosine, inverse tan. I thought I'd start out with that. That was a mess, but there was an answer. And Matthew, you and I mean, I'm included, I would have said this from this old property that we've had. And by the chopping off that graph somewhat, it messed us up. Okay. Now we'll jump into, guys, where I should be here. I have a handout right in front of me, but I'll call on Jacob at points here to help me here. Jacob, just read the directions for number 1 there.
Write the given trigonometric expression as an algebraic expression in U.
Now, that's calculus. They did not give you a number to work with. They just called it U. Okay, some variable. Now, he says, the first one, he says, do that, Professor, and the first one looks like this. Sine, inverse cosine, U. Tell me, how on earth can I get a start on somehow simplifying this, creating something with it? Help me out, guys. I will tell you this much. I'll get you started. Does this translate into, does it mean there's an angle out there when you take its cosine, you get U? Is that the translation just for that argument? There's an angle out there whose cosine is U. Now they want sine of that. Any ideas? You will be pleasantly surprised when you see it. Any ideas? Let me give you a hint. Is there something we've done in class that relates sine and cosine? Well, sine over cosine is tangent. Something else that's just with sine and cosine. Sine squared plus cosine squared is equal to one. A basic trig identity. I will turn to that for help. And look at this, guys. Got sine squared plus cosine is merely u, so this is u squared. And then if I solve for sine, which they want sine. So this is sine squared is equal to 1 subtract u squared, and take a square root, and it looks like that. Now, it's tempting to say this is a nice perfect square root, Professor. Can't you go one step further, Professor, and simplify this into this? Yes or no? No. The square root of that 1 subtract u squared is not merely 1 subtract u. So I gotta stop here, Nathan. And we have now square root 1 minus u squared. This is this expression. And that's my argument. My work. We're done. That's all they wanted. The next one there, let's call it part C there. Jacob, tell me what the next one's asking.
Tangent equals sine or inverse sine of u.
Hang on, inverse sine of u. Translation, this means, I'll do it quickly here, this means there's an angle out there whose sine is u. No numbers, no specific number there. Now, it's up to us. Can someone come up with a relationship and identity that somehow, I don't think there's a direct one, but somehow it may take a couple here on this one. I don't think it was as easily done as sine squared plus cosine squared. Matthew, go for it.
Sine over cosine, so we can have u over cosine equals tangent.
Getting close. I know what you're saying. Tan is sine over cosine. I think I need something else first. I think.
Couldn't you use sine squared plus cosine squared equals 1?
Okay, now hang on.
Cosine.
Okay, beautiful. Let's get this started first. You're saying, Professor, go ahead and use this. This is what? U squared plus this. And Matthew, I'll get back to what you said. This is u cosine squared. Equal to this. Cosine is equal to square root of this, which is much like what we had here. Did we do that correctly, guys? Did I move things around correctly? I hope I didn't mess up. Is that true with what they gave me? You guys are watching? Okay. Now, Matthew, you're saying now after that, Professor, let's call that step 1. Step 2, tangent, which they want. He recalls tangent as an identity with what? Sine over cosine. Look at this. This is UCLA. Being serious. And sine is u.
U over
And?
root 1 minus v2, and then you square it.
You know what? You know what? And in fact, at UCLA, they're so happy if you get to that point on a problem like this, they leave it. I'm going to rationalize though. Tell Matthew, tell us what it looks like.
Okay, wait. It would be u times root 1 minus u2 over 1 minus u2.
Beautiful. And there's your expression. Okay? And I can try others with you on the exam next Wednesday. Relationship. Now this is what you guys are going on in math, maybe math 7, math 8, math 11, take all the math you can. This is what it's all about. We're beyond 3 plus 3 is equal to 6. This is what it's all about, looking at relationships here. Now, Jacob, check, I think that's all I asked in part 1. Now, yes, go ahead.
Just a question, so whenever you have those type of questions, you're just trying to solve the argument in terms of u?
Can we get now?
When you have those type of questions, like,
Yes. Yes. Okay, and I use my directions, I think on that handout, just like your textbook used, the same directions. Yeah.
Say we have another equation with tan of inverse sine
Beautiful.
equals.
Tan of, now I did a tan of sine of inverse cosine. Okay, a tan of inverse sine, we did that, okay.
And then we put in a value for
Oh, you're, that's exactly where I'm going. That's exactly where I'm going. Not quite yet, that's exactly where I'm going. Ramsey's good. Now, Jacob, go back to the other handout that was, we were working on Monday. And I don't think we touched any of those at the bottom down there. Did we? Now I'm going there. I'm gonna write this out, guys. Everyone has a handout. And then he's seeing something that we don't see yet that's gonna be helpful if we can remember all this. Okay, I'm gonna call this part 2. Jacob, please tell me, read the directions there for us for that particular part down there.
Find the exact value of the given expression.
Now, hang on now. Fine, let's make it brief. Find the exact value. And how many problems were down there? 4?
4. The first
Give
one.
me, what's the first one look like?
Sine of and inverse cosine of 1/2.
Okay, sine of inverse cosine 1/2. Now, if you're USC, you'll tell the professor, wait, professor, we've already established right here, here's the formula. Does that problem there look like this?
Yeah.
Therefore, the answer should be merely square root of 1 subtract what here?
1/4.
1/2 squared, exactly.
Oh, sorry.
That's okay. Square root of what? 1 subtract what? 1/4? Or the 3/4?
Yeah.
Simplify this into radical 3 over what?
2.
2, and you're finished. Now, how many students? There are students on this campus I've talked to. They walk around, they know these. Some people are just different. I met students in grad school. Their mind is just like that. They have this logic in their mind. So when you ask them to do this, they'll quickly do it when in their mind they remember it was this. Now, do I myself remember all these? No. I have other things to think about. But you have some whose mind is just focused on that one thing. And I enjoyed math, but after I got one part done, usually I forgot a few pieces of it until I had to use it. But they just walk around and they know. Now, suppose I'm one of those that did not know the formula, and I'm embarrassed. I'm embarrassed. All of a sudden, somebody in my group says, "Ramsey, answers that." I say, how'd you get that? This. I didn't even think about this myself. Can anyone tell me another approach that you could take and get the same answer? That's what this lesson's all about, connections today. You just go up to a Math 7 or Math 2 student and ask them to find this. Some might relate it to this. I see another way to get it. What's the other way to get it? In fact, I see a couple ways to get it. Besides the formula. Because some students just don't like to memorize formulas. Jacob?
Couldn't you plug in 1/2 for you, and then you have cosine of theta equals 1/2, and find out what cosine of theta?
Well, of course. This says right here. There's an angle out there whose cosine is, and since he's giving me a number, is 1/2. Well, my goodness, that's on the unit circle. I think there are a couple of angles whose cosine or x coordinate is 1/2. Guys, give me the one in quadrant 1. That would be the most convenient one.
Pi over 3.
I hear pi over what, 3?
Yeah.
If that's true, then you're going to finish up and not be too embarrassed and say, oh, my goodness, professor, this says merely take the sine of pi over 3. The y coordinate. Is the y coordinate at 60 degrees pi over 3 radical 3 over 2.
Yes.
They match. I have some students in this class, I sort of have an idea. They love math, and I bet some of my students right here seated tonight, more than likely will recall this weeks from now to get an answer like this. Me, and some of my other students, I'd probably say, ugh. I'd probably think about, oh, I'm going back to the unit circle and get the answer. And it works out. Tell me what the next one is.
The next one is secant of inverse tangent
I got that.
of
Okay.
root 3.
Root 3.
Not inverse secant, just normal secant.
Oh, secant.
Yeah.
Okay, guys, this tells me it's this. Now, when I did my planning, I think this is a beautiful worksheet. I think, here's me thinking, can anyone tell me, is there a spot, or maybe 2 spots on the unit circle, angles, that has a tan of, that's what this means, that has a tan of, looking for this, radical 3.
Pi over 3.
Now, if it's pi over 3, now hang on, if it is, I'll put it on the side here. Pi over 3 from the unit circle has coordinates of what, 1/2? Radical 3 over 2. And tangent is y over x. You place radical 3 over 2 over 1/2 y over x and simplify, you get radical 3. So you say, wait, professor, this is merely pi over 3. That's what we're talking about. You guys agree?
Mm-hmm.
And then it says now take secant of that. Well, secant is what? 1 over x or 1 over cosine. And the x coordinate is what? 1/2? So is it 1 over 1/2? No, I guess the answer is 2.
That within.
Is that true?
Mhm.
Now that's without a formula. Yes or no?
Yeah.
Now, I did not do a secant with a tan over here. Okay, now see, let's do one. Let's find a formula. Let's see if it works. Formula to connect these two, or an identity first, would be what? 1 plus tan squared is equal to what? Secant squared? Of course. I know what tangent is. It's radical 3. So let's put that in. That's true, guys. This is one way to do it. This 1 plus 3 is what? 4? And take a square root. Is that a possibility there?
Mhm.
That I could translate in my mind what's going on. The truth? And probably if they ask you to express it in terms of u, like I did these two, you probably could come up with a formula in terms of u, if you had to. Okay. Are we okay here, guys? I think if I planned it correctly, we'll run into an issue here shortly. Okay, letter C, Jacob, what was it?
Tangent of inverse sine
Oh, my goodness, okay.
of 1/3.
Now. Oh, Ramsey, you are good. You are good. Levy? Did we do one? Did we do a formula for tan of inverse sine? I thought I was board somewhere. This one?
Oh, we did.
We did a formula. Which one? What was that formula? This down here? The crazy one. We did do it. Now, Mr. Professor, I'm really caught on this one. I'm not a formula type person. I may forget these formulas. Who on earth walks around and remembers this? Which I am going to apply to this problem. Nathan, if I don't know this formula, you'll say, Professor, do it like you did the others. Out in the unit circle. Well, it's sad. You've never seen a 1/3 to work with on the unit circle. It says there's an angle out there whose sine is what? 1/3? You can't do that without a calculator. You can't do it as I did the other two. So you're almost forced into a formula. And then we'll show you another way you could approach it, even though it's not on the unit circle. Laura, right now though, I'm going to depend upon this formula and say the answer must be, here we go, don't let me mess up here. What is that, 1/3? Square root. 1 subtract what? 1/3 squared. Guys, let's go ahead and call it 1 subtract 1/9. Do not let me mess up on this all over. What a mess. 1 subtract 1/9. That's 1/3, then I'll get out of your way here. That's the square root, what, 8/9? Look at this. All over 8/9, I guess. Looking crazy. Simplify this further, that's 1/3 over, you know what square root 8/9 simplifies into? It's 2 radical 2 for the 8 over 3. See if you guys agree. Over 8/9. Is that true? Go further. On top there is 2 radical 2 over 9 over 8 over 9. Well, how cute, the 9s will cancel. So at this point I have 2 radical 2 over 8. Please do not let me make a mistake. Reduce that down to what? Radical 2 over 4. Are you kidding? Oh. You're seated there, say, Professor, I can imagine the final exam, Professor. I've got other formulas, Professor, to worry about, besides these new ones that look so strange on the board tonight. So, Professor, can I approach this some other way, even though I cannot approach it with a unit circle, like I did these two, because of that 1/3? Is there some other way besides the formula, Professor? Well, let's take a look at it and see if we can. Watch what's going to happen. Here's another method. This is done. Nathan, mathematics. It says there's an angle out there whose sine is 1/3. Put a comma. That's an inverse. That was inverse, though, wasn't it? Was there a restriction on where that angle might be located? Does anyone remember the restriction? Now, I'm talking about the range.
0 to pi.
Inverse sine.
Negative pi over 2 to pi.
That's what I want to hear. Negative pi over 2 up to positive pi over 2 is where the angle must be located. Now, guys, I know what the answer is by formula is this. We're trying to confirm now by another method, thinking about this, we get the same answer here shortly. Does anyone agree so far? Okay, negative pi over 2 up to a positive pi over 2 inclusive is that. If you think about negative pi over 2, guys, negative pi over 2 is represented down here. It's also 3 pi over 2, but is it negative pi over 2 also if you go the other direction? So you call it between negative pi over 2 and a positive pi over 2. Does that mean the angle must be either in quadrant 1 or quadrant 4? It's a positive 1/3. Where is sine positive? Quadrant 1 or quadrant 4? Love quadrant 1. What is sine, by the way? S-I-N-E. What is its sign down in quadrant 4? Negative. In y coordinate negative down in quadrant 4? So I want a positive 1/3, so since it's positive, I must be here. That angle is located here. I have no idea what size it is. Suchin's going to find the size of it on the calculator for us shortly, but right now I don't know myself. Is it 20 degrees, Professor? Is it 32 degrees, Professor? I have no idea myself. Notice I turn to a calculator. You say, Professor, what are you going to do with this second method? I'm going to draw a perpendicular. Make this cute and have a right triangle. I'm going to assume this is on a unit circle. You got it? Something like this. And therefore that red is going to be a 1 if I go back to the unit circle. That true, guys? Now I know sine, the y coordinate should be what? 1/3. Could I place that 1/3 on this vertical side here to represent sine? That's the y. Use Pythagorean theorem, and I don't recall, or I don't know how many students do recall this. This is a good lesson tonight. This is UCLA and others. Let's call this a squared is missing. B, let's call it 1/3. Guys, I got what? 1 subtract 1/9, help me out. That's 8/9, I think. I'm doing it quickly. Do a square root, 2 radical 2 over 3. That goes here. Do we agree so far? Can I do that? So far, so good. Far on the graph? Now, what do they want? They want tangent. So what are you going to do? You're going to place the y over the x, simplify it. We're hoping you'll get this answer here. And we did by formula. Okay, let's find it here, guys. Tan would be y over x, sine over cosine, 1/3 over this. 3's cancel. Matthew, I need you.
Root 2 over 4.
Root 2 over 4. When you rationalize and clean it up, does that agree with the formula answer?
Yes.
Well, hey, that's, you're not gonna be ready for Math 7 unless you understand this. And Math 8, those instructors are gonna get really upset. So if Ramsey didn't show you that, don't you dare mention my name. Oh, cause I'll know what I did. Some students are going, Ramsey didn't show us that. Oh, no. No, I'll find you. Nathan, don't say anything about Ramsey. Okay, guys, you agree? Okay, now, Suji, they could not do this. I want you to do a favor for me. Would you do inverse sine, let's do it in degrees, of 1/3, which is not an angle that you guys are accustomed to.
Inverse sine of 1/3.
Uh-huh.
In degrees, I got 19.47.
47 degrees. Now take tangent of that.
I'm getting 0.35.
0.25?
35.
35.
Mm-hmm.
Now we got this answer. Now find out what radical 2 divided by 4 is.
0.35.
I have some students, I guarantee you, who are there and they're seeing that, oh, I love this. He does this and he goes there and he gets this, and we all end up at the same point. Except I could not, Nathan, ask you guys to do it the way she did right here, because you had no calculators. But it agrees, you got a calculator. So far, so good? Now, do I have one more in that section
Yeah.
to look at? Man, this is a lesson here. Letter D, we'll squeeze it in right here.
Cosecant,
Wait, cosecant.
inverse tan.
Inverse tan.
-3.
-3?
-2.
-2. Jacob, like this?
Correct.
Okay. Now here's the issue again. I've got cosecant with tan. I did not develop a formula over there, did I? So I can't use a formula. I have no formula. Unless I want to do it myself on the side here, like I did these. This says there's an angle out there whose tangent, translation, is -2. I don't think you guys have ever seen on the unit circle with those numbers we were responsible for. If you place y over x, did anyone ever see tan come out to be a -2? No. Not for those I asked you to be responsible for, pi over 3, pi over 6, pi over 4, those other reflections. No. So it must be one of these crazy angles, like she's gonna find over here later, like this crazy thing that just came out to be, where was it?
19.3.
Yeah, 19 point something there. Maybe one of those types. So I can't use the unit circle the way we would like to use it. Does anyone have an idea? How can I still find cosecant of tangent? Who on earth would think cosecant was tangent? where tangent has been recognized as -2. And by the way, for the comma here, since that's an inverse tan, where is this angle supposed to be located? Someone's going to help me out. What was the restriction
On
that we gave?
pi/2.
-5/2, was it? Open this time? Up to what?
Pi/2.
5/2 open because of those asymptotes. You with me, guys? Goodness sakes, stay with me. Okay. Now that's either quadrant 1 or quadrant 4. Nathan, here goes. If I quickly make a sketch, watch carefully. I may mess up myself on this one. I want tan to be a -2, negative. Quadrant 1, quadrant 4, that's what this says. You're supposed to be located either there or there. Which of those two quadrants, when you place y over x, will give you to begin with a negative? Quadrant 1 or quadrant 4? So you're down in quadrant 4. So that angle I'm looking for, I have no idea what size it is, it's down here. In quadrant 4. Hang on, because I won't drop a perpendicular and so forth and so on here shortly. Does anyone, Austin, I saw your hand go up. You have an idea as to how to approach this last problem?
Yeah, I just said, sine equals cosine equals -2.
Okay, hang on, I agree
Do it on
with
the
that.
graph.
Hey, okay, got you. You're saying sine over cosine. I will absolutely agree 100%. Class would also, that's tangent, you're saying professor, that's what it says. Tan is equal to a -2. Yeah, tell me more. They want cosecant.
I wanna get like sine cosine separately, so like, you write it as like sine equals -2 cosine, and you use the.
Whoa, so you're saying rewrite like this, it's multiplied by cosine, from what I think I hear you say. Yes or no?
Yeah. And you write the sine squared plus cosine squared.
Oh my goodness, you're gonna get a formula for me.
Yeah.
Whoa. Hang on. This is what it's all about, guys. This is the last one we're gonna do here. Austin, and your brilliance here. You're saying sine squared plus cosine squared. This is beautiful. Equals 1. Okay, what are you gonna do from there?
Then you like, substitute.
Substitute sine maybe?
Yeah, to -2 cosine squared.
Okay, that n squared. Got this. Oh my lord. Now we're gonna see if it works. Okay, hang on. So you got what, 4 cosine squared? Help me out.
Yeah.
Plus another 5 cosine squared?
Yeah, so cosine squared equals, 1/5.
Are you kidding? Cosine squared is equal to 1/5?
Yeah.
Take a square root. You got cosine to be equal to, Matthew, I'm ready for you. What's the square root of 1/5 simplified?
5√5/5.
Hey, look at that.
And it can only be positive because it's.
Because I'm in quadrant 4,
Yeah.
cosine's positive in quadrant 4. And now he tells me, Professor, they actually want cosecant. Don't they?
Yeah.
So I'm not quite finished. I got cosine, now I gotta find cosecant. So what now?
You can get the sign from the thing we established before, sine equals -2 cosine.
Oh, you may go back to here and replace that cosine with the radical 5/5 here and find out what sine is?
Or you could just place it earlier.
The earlier
Sine
one.
theta.
Or the earlier
Sine
they
theta.
said, on this one, what was
So
it?
sine of theta equals -2 cosine theta.
Oh, back here.
Yeah.
Oh, wait, hang on now. Oh, listen to this. So you're saying, Austin, geez,
Yeah.
sine theta should be equal to a -2 times this mess.
Yeah.
Wow. Wow. So -2 radical 5/5.
Yeah,
Yes.
then you get the
In
cosecant.
There you
Yeah,
go.
then you get the reciprocal.
And you want to do a reciprocal to find cosecant. And you will flip that over. Okay, Matthew, I'm ready for you again. And you're gonna end up with a negative answer, it looks like.
Okay, that'd be that'd be 5√5/10.
I love that.
Well, a negative as well.
And could you even reduce this fraction down for me?
5/2.
Yeah, negative radical 5/2, listen to that. Oh my goodness, Austin, class, I guarantee you, if I were a beginning student seated and Austin was telling the professor how to do, I think this professor, I think to do this, I think to do that, I said, what? What? I don't have a clue. What? That's cosecant, that's what they're asking for.
Yeah.
So you're telling me, Austin, with all that, this answer, it should be this. And by the way, we've already determined we're in quadrant what, 4?
Or, yeah.
And cosecant down there should be negative.
Yeah.
So I know the sign is correct. Now before I have to do anything else with it though, you Susan. Oh, we got to check his brilliance here. Do it in degrees. Find out what inverse tan, and put in a -2 and see what it shows for that.
Negative 63.43.
43 degrees. Beautiful. Now take, on the calculator, I think you're going to take sine first of that, and then do a reciprocal on it. But first take sine of it.
Sine of negative 63.43 is negative 0.8.
Negative 0.0 or 0.9?
89.
89. Okay, that's sine.
Yes.
Now do 1 over that or reciprocal.
Negative 1.12.
1, 2. She says, by calculator, professor, the answer to this mess is that. Austin says, hold on, professor. The answer is, where on earth did I place it?
On negative.
I'm now lost with all this business here.
Negative.
circle,
The circle, the circle.
Oh, right here. Do we have a negative sign there?
Yeah.
Now find out what radical 5 divided by 2 first is. Just radical 5 divided by 2
It's 1.12.
with that negative prefix. Congratulations. Congratulations. I was just wondering how many students in other classes are doing this. Mr. Park, I think we did this when I had you in MATH2, didn't we?
Mm-hmm.
Hey, Susan, you remember doing some of this in MATH2 with me? It's been too long
I'm
since
a
you.
Christian, never a fresh. I don't
As you said,
remember.
I'm in Math 7 now, Professor, that's enough for you.
Yeah.
I don't have to worry about this. Now, I saw some hands going up, because this is the last one of this, guys. These can get crazy on you. Crazy on you. Austin, congratulations on this. You could use his method and finally come up with a formula in terms of U, and then use that formula to get this strange answer of that. Or, here we go. Since I have a sketch already, and Deborah, I saw your hand going up, and we'll get to you. We know you're down in quadrant 4, don't we? Suppose I drop a perpendicular, here's alternative. Drop a perpendicular here. Let's see if I can use a different color now. Okay. Up to the x-axis, Nathan will do this, form a right triangle along the x-axis. What do we know about the angle? The tan is -2. I know tan should be y over x. Would that be okay to replace this by -2 and this by 1?
Yeah.
Watch carefully, guys. This is a little shortcut to get Austin's answer a little quicker. I love what he did though. C squared is equal to A squared plus B squared will give me, without me showing you, what would Pythagorean theorem give you if you use C squared is equal to A squared plus B squared?
Root 5.
Root 5
over 2.
Hang on.
Oh, sorry.
I think it's root 5, isn't it?
Yeah, that's my bad.
Is it just root 5? Now, here's the trick. If you want to do it graphically, visual, and I'm more of a visual type person. We're accustomed to this red here to be a 1 for a unit circle. Is that true, guys?
Yeah.
We like a 1 for the unit circle to make it much easier. Well, let's make it a 1. It's a radical 5 right now. Let's make it a 1 so it looks more like what we're accustomed to. How? Divide this by radical 5. But if you do it there, you gotta do it here. And you gotta do it here. Now it's a unit circle. And what do we want? We want cosecant, which should be what? The reciprocal of this, the y. If I go to this side here and flip it over to a reciprocal, where did I get that answer?
Yeah.
There it is, visually done. Look at the faces on some of my students are looking at Ignacio saying, Ramsey, what happened? I used to be in classes, all of a sudden I turn around, what happened? My friends would say, Ramsey, did you see it? No, I didn't see it. In other days I saw it and they didn't see it. Isn't that cute? Austin, though, mathematically, Austin, I love what you did to finally end up with this. You went through all this business, made relationships and all that. A lot of my students will do that. Here's a visual. If you want to approach it visually, make some sense of it with the right triangle. That business, you can do it. Tell me, Jacob, please, it took a little time here on this. Is that the last of that?
That is the last.
Oh my goodness. You say, Ramsey, how many of those are gonna be on that exam next Wednesday? You still have room in your winter class, Ramsey? So that's exam, maybe something else. How many of those? I can just put a couple of those. I can't go crazy on this. I wish I could, but I can't go really super crazy, okay? Now, let's go now to where we should be, back on the other side there.
6.3.
Okay, hang on. I wasn't saying solving equations?
Solve the given equation.
Now,
Correct.
I'll be able to do one, then we're gonna take a break. Before we take a break, I wish those professors, the one who looks through the window, always, you know who it is, always looks through the window back there. Professor Wayne.
Oh, really?
He always looks in and sees what we're doing. And then the one who was sitting in the back there, I wish they both were here today, just to see what's going on. This is heavy, heavy stuff. You might wish you were back on logarithms. Won't go back to logarithms, but sometimes students say, Professor, this is way too much trig. I like trig. Look at all these relationships going on here. Let's go back to logs. Or better yet, let's go back to a parabola. Remember all that? Find the vertex, negative b over 2a, right? Put a smile back on my face, Professor. If you show me something like this, like Austin just did for us, you may see me crying. That's crazy. Okay, let's try one of those solving equations and we'll take a good break here. Jacob?
Yeah.
Now watch carefully. This might be a little easier. Deborah, I did not want to overlook you. What was your question?
Oh, I was just wondering if instead of doing Austin's way, if you could do 1 plus cotangent squared theta equals c
Whoa,
cosecant squared
whoa,
theta.
whoa, whoa, whoa.
Because you already have a tan. So
Hang
I
on,
could just do.
let's see the work. She said, wait, Professor, and this says tan is equal to a negative 2. And she wants to use, I think, 1 plus cotangent squared.
Yes.
I think you want, which is an identity, is equal to that, okay? And since tan is negative 2, you might tell me then cotangent might be, if I want a replacement, is what? 1, flip it over, negative 1/2?
Yeah.
Okay.
Where there's 1/4.
Wait, 1/4. Let me put that in for all students to see it. Deborah, hang on. So that says what, 1 plus 1/4? That mixed up here. And what is that, 5 over 4?
Yeah. And then you root it.
Hold on, take a square root. Radical 5 over what, 2?
Yes. But you don't get the negative.
Yeah, but then you had, well, if she gets to that point, she's gonna get a big smile on her chest drawn. Look at that. Another way to approach it. Now, do you see a way to pick up the correct sign? Because you know the angle's down here. And we were asked to find, what was the cosecant? So cosecant must be what, negative down here? And you have to remember that, and prefix that answer with a negative. Wow. And I'm sure there's other ways to do this. Okay, guys, I gotta do something real quickly. Jacob, tell me the first one on the solving equations.
Cosine of theta equals 1/2.
Hang on. Cosine theta is equal to 1/2. Did I have anything on the side there?
No, just a line.
Just find it, right? Just find it. Here we go. Guys, this is on the unit circle. So on your exam on Wednesday, next Wednesday, if you see some of these, I cannot give you something crazy like 1/3 over here somewhere. I cannot do that. You have no calculators. So I gotta give you something you recognize. This one you'll recognize. Does anyone recognize where cosine is? Just straightforward. Cosine, the x-coordinate, is 1/2. Pi over 3, was it?
Mhm.
And I think also they want all of them. This is not an inverse, there's no restrictions.
5 pi over 6.
5 pi over 3.
5 pi over 3. And within one revolution, are those the only two? Within one revolution.
Yes.
Now see, no inverse symbol on this. So there's no restrictions. Now, before I leave it and before we take a break, Jacob,
Yeah.
I'm gonna ask now, I'm gonna call it this. Then we're gonna take a nice, well-deserved break. I want now to pick up all the answers. I said, Professor, that's it. No, you could go another revolution, and another revolution, and another revolution. Can anyone tell me a nice way to express and pick up all answers out in the universe, besides the two we have now? Jacob, go for it. Let's pick up.
Wouldn't it be,
Theta is equal to
theta is equal to pi over
5 over 3. Now, Jake, before we go further, let me
Yeah.
remind the class.
plus, and then 2 pi n. But
Yeah, I think I used a K the other day. That's okay.
Yeah.
That's okay. That's okay.
shouldn't you also put plus minus because technically?
Well, no, because K is going to be any integer.
Okay, and then 5 pi over 3.
Hang on, hang
Oh,
on.
you have to do that too.
Will this pick up all of them?
No.
No.
Okay. Well, on the pi over 3.
Yes. Yeah.
And then he said, hold on, Professor, you have another one to consider. What, 5 pi over 3?
Mm-hmm.
And plus 2 pi k. I think your textbook uses a k. Where k is an integer. And we know what integers are. Let me remind you, for goodness sakes, you get to replace k by these numbers. A set of integers. All that. So Jacob, I would pick up my negatives here. So we don't need a plus and minus. Guys, those are my general solutions. In other words, that picks up all of them. Now, I listed just within one revolution, I think your textbook, the author of your textbook wants you to just list the ones caught here between 0 and 2 pi. And he may leave that 2 pi open, I think he does. Therefore, he would want the particular solutions to be merely what we had here. If I say list all of them, the best you can do here, Nathan, is say, Professor, you want this. This would pick up all of them. Okay, so general solution and the particular solutions. Now, I know we're going to take a break here. Let me replace k by a random integer. Just pick out an integer. I'm going to try 10. Just random, 10. If I put a 10 in here for k, that makes that what, 20? 20 pi plus pi over 3. Okay, 20 pi plus pi over 3, common denominator of 3. Is it 61 pi over 3? That's a crazy number. 61 pi over 3.
That would be 20.
You're hoping that when you take the cosine of it, you get 1/2. 61 pi over 3, then we're going to take a break. Okay, guys, here it goes. Sophia, I do mine like this. I know some of you guys on a quiz or an exam, I saw you doing this. This is 20 pi, this is 60, with a what, pi left here? Is that true? I did quickly.
Mm-hmm.
So that means you're going to move what, 20 pi, how many revolutions is that, 10? 10 complete revolutions, and then stop there after 10 complete revolutions, and then move an additional what, pi over 3?
Mhm.
Does that take you right back into quadrant 1?
Mm-hmm.
And therefore it takes you right back to
Pi over
that true? Lord, you guys need a break. Okay, take your 10-minute break.